All right, we're doing section 10.6 right now in geometry, and we are going to talk. First thing we're going to do is do a definition. All right, we talked about the tangent yesterday. What did the tangent do? It was a line, right? That did what? It hit a circle at one point. Okay, so we talked about that. Now what we're going to do, we're still going to talk about a line. It hits the circle, but how else could a line hit a circle?
Could.
How else could just a line, a single line, hit a circle? We said a tangent hits a circle at one point, so this one's going to hit a circle how? At 2 points. Very good. All right, so it hits it at 2 points. And we have a name for that. The other one was tangent. This one is called a secant. S-E-C-A-N-T. Not sure where they're getting these words from, but it's called a secant. All right, and that's it. Hits at 2. Let's not pop the gum, please. It hits at 2 places on the circle. Everybody got that? So really, anytime a line is going to hit the circle, it only hits the circle in one or two ways, as a tangent or as a secant. All right. Now, if it just hit at 1 point, some people are thinking, "Oh, I could draw a line that only hits at 1 point." Boom, right there. That's not a tangent. That's not a secant. It only hits at 1 point. Well, it really does it if it's a line. Oopsie daisy. If it's a line, does that really hit at 1 point? No, because eventually, what's it going to do? Charlene, what'd you say? It keeps going, right? And hits the other line. So if it's truly a line, it'll just keep on going. So it would be a secant, wouldn't it? All right, the only time a line hits a circle at 1 point is when it's a tangent. All right? Someone going to help him out a little? All right. So that's the definition of secant. We good with that? All right, let's pause. All right, now what I'm going to do, I drew one line, but we're going to draw 2 lines, 2 secants. All right, so here's one secant, and specifically these secants are going to intersect each other, but they're going to intersect inside the circle. All right, we're going to do one a little bit later where 2 secants intersect outside the circle. Okay, this one is inside the circle. Everybody got that? All right, it can be anywhere. They can intersect anywhere as long as it's inside the circle. All right.
Please excuse the golf team. Thank you.
Golf team. All right. See ya. It's a nice day to play golf, I tell you that much. I wish I was on the golf team.
No, not today.
Not today. Who are you playing today? Sally's. Have fun. Hey, Jordan. Look on YouTube for the rest of this and for the lesson. All right, here we go. We got 2 secants. I'm not going to draw the arrows, you know. Oh, my goodness. All right, here's our situation right here. We have 2 secants that intersect inside the circle. Now, what happens is they cut off arcs, just like we've talked about before. And look at the arc. Let's call this angle 1 right there. And let's just go 2, 3, and 4. That's supposed to be a 3. What's 1 and 2? We had a name for that. We learned it a while back. We've used it quite a bit. What is it? Vertical angles. They're vertical angles. 1 and 2 are vertical angles, and what? 3 and 4 are vertical angles. What's true about vertical angles? They're equal. They're congruent to each other. Okay, so 1 and 2 are the same. 3 and 4 are the same. You with me on that? All right. Now let's go to the arc that angle 1 cuts off. See, angle 1 goes from here to here. What arc does it cut off? It cuts from here to here. Agreed? All right. So let's just kind of mark that just so you can see it a little bit better. Look at angle 2. Angle 2 is the same angle as angle 1, isn't it? But it cuts off an arc down here. Are those arcs necessarily equal to each other? No, they're not equal to each other. Not necessarily equal. Not necessarily equal to each other. Now, if that point of intersection was right on the circle itself, then they would be, because the angles would be equal and the arcs are equal to the angles, so yes, they would. But if it's not, if that point of intersection is not at the center of the circle, that's not going to happen. Make sense? Now, we have a formula. And let's call this A, B, C, and D. All right? We have a formula for this angle, actually for all these angles, but I'm just going to pick one. Let's just say angle 1. And angle 2 would be the same thing. Why? Because angle 1 and angle 2 are the same. They're equal to each other, congruent, right? All right, so here's the formula. Angle 1, now again, look what I said. Angle 1, angle is not equal to this arc, is it? It would only be equal if it was a central angle, okay, if the vertex was at the center of the circle. It's not, so it's not equal to it. Obviously, arc AB and CD are not equal to each other as well, right? But there is a relationship between them, and I'm just going to write it down. Angle 1 is equal to 1/2 of the sum of those 2 arcs. So if I add up, sum means I'm going to add up. If I add up the 2 arcs, AB and CD, arc AB and arc CD, and I take half of it. Okay, don't forget to do that. It's kind of like the average, isn't it? You add two things, you take half of it. That's how you do the average. That's basically what it is. This angle right here is basically the average of these two arcs. Can you remember it that way? Okay, it's kind of nice. This is a plus. This is the only time. We're going to learn a few more equations. This is the only time where it's going to be plus. Everybody got that? All right, so this is the plus. So I add them up. Let's just make something up. Let's say, actually, I think, let's use the numbers they use in the book. They have an example. We used this in the other class. We'll use the same one. So let's say that arc right there is 84 degrees, and let's say this arc down here is 130 degrees. It's supposed to be a 3. And I want to find what angle 1 is actually equal to. Well, this is as easy as it gets on this equation, right? Just plug and chug. Take angle 1. What's it equal to? Well, it's half of the sum of these two arcs. This is how I write it out. I rarely put the 1/2 out in front. I would do this. I would go 84 plus 130. So you take the two arcs and you add them together, and then what do? You take half of it, or I would divide it by 2. I think that's just a little easier, don't you? All right, so 130 and 84 is what? 214. Angle 1 is 214 divided by 2. That's 107. So that's how you would find that angle right there. It's not too bad, is it? Look, once you find this angle, you could find these arcs, couldn't you? Or these angles right here. So if this is 107, what's this angle 4? And this is going to be 107 as well, right? Because they're vertical angles. What's angle 3 and 4?
60.
What is it? 63? Okay. Good. So that's going to be 63. Is that right? 73. 73. I was going to say. Okay. That looks better. So that would be 73 degrees. Now watch this. Nope, you couldn't. You could tell what they added up to be, but you wouldn't know what they are individually. So I was thinking, oh, you could find out what these arcs are. Now you could find out what they add up to be. But yeah, you couldn't say, okay, this one is this angle and this one is that, unless you knew just one or the other. Yeah. So I was going to go somewhere with this, but ground to a halt on that one, didn't it? All right, so anyway, you could find those angles right here. Now you could find the sum of these angles. That'd be easy. That would just be, what, 214. How would you find the sum of the two angles? Just take them away from 360. That's right. Just take them away from 360. Now I don't know it individually because I know they're not equal to each other, and I don't know like how much bigger one is than the other, so I couldn't really do anything after that, could I? All right. So there you go. That's two secants, and where do they intersect? Inside the circle. All right. Might want to jot that down in your notes or something. Two secants that intersect inside the circle. Because what did we say we're going to do in a few minutes here? We're going to do two secants that do what? Intersect outside the circle. We'll do that in a few minutes, okay? All right, here we go. We're going to do one more thing before we probably get to the next video. We're going to do a secant, and what did we talk about yesterday? A tangent. So we're going to do a secant and a tangent. But, now, can you have a secant and a tangent intersect inside the circle? Why not? Wouldn't be a tangent. That's right. The tangent would never go inside the circle, would it? So, if I had a secant and a tangent, they intersected. I guess they could intersect outside the circle, couldn't they? But we're going to have it intersect, what do you think? On the circle. Good. Okay, so let me draw that for you first. All right, so now we have a tangent down here on the bottom, and we have a secant right here. And let's mark some of this stuff. Let's call this, again, let's go with the ABC, might as well, right? Yeah, we'll call this B. And let's say call this C up here. All right. So watch what we're going to do. Those two things cut off arcs as well. Let's just talk about this. Let's talk about this being angle 1. See that right there? And we'll call this one angle 2. This one right here. All right. Look at angle 1. Look at the arc that angle 1 cuts off. Do you see it? What is it? What arc does angle 1 cut off? Give me the name of it. AB. Good. All right, so let's draw it. Okay, that's close enough. All right, so it cuts off that arc right there. Now, it's on the circle itself, okay? So here's a new theorem, and it's angle 1, and I've got arc AB, and so let's put the marker here. So angle 1, oops, a little thick. Let's make this a little smaller. There we go. Angle 1 equals half. Again, half comes into play on every single one of these, okay? So it's easy to remember. Half of the arc that it cuts off. half of arc AB. All right? So watch. What do you think that would be about 90, wouldn't it? So what do you think this arc is? Right around 70, 60. Let's say 60, make it easy, okay? So let's say arc AB is 60 degrees, and it asks for angle 1. That's not very hard, is it? Angle 1 is equal to half of 60, which is 30 degrees, okay? So angle 1 right there would be 30 degrees. And you could find the other stuff too, couldn't you? You don't even have to find this angle to find this arc ACB. What would arc ACB be equal to? This is 60, right? 300, right. Okay, see, he was going to pull his calculator out, and he thought, I can do this. 360 minus 60 is easy. It's 300, right? So it's 300 degrees. So this arc right here is 300 degrees.